monoliths versus microservices. Suppose we are developing a server-side enterprise application which supports a variety of different clients including desktop browsers, mobile browsers, and native mobile applications. The application might also expose an API for third parties to consume. So basically there are logical components corresponding to different functional areas of the application. So the biggest question arises is which architecture style should we follow to develop an application into. So first we will discuss what is monolithic architecture of designing an application. So what are monoliths? So as you can see here, we have two clients, passenger and driver. They are going to connect to a application which is behind a load balancer, right? And this application is basically, for example, let's say an Uber or Ola kind of application which has multiple modules inside it, like trip service, map service, notification service, and bunch of other services as well. But all of these modules are bundled together into a single application. They have a single code base. All right, monolithic architecture is built as one large system and is usually one code base. They have a shared database which is shared among all the modules inside the application. The whole application can be packaged in a single deployable unit. For example, if we are developing a Java based application, then that single deployable unit can be a jar or a war file. Communication between different modules or different functional or business units will happen via a normal method call. Alright, what are the different advantages of a monolithic architecture? It is simpler to develop. The second advantage is it is simpler to deploy. Since we have only one application, then it is very easy to deploy that application because we can bundle that particular application into a single jar or waterfall and we can deploy it into a Tomcat or a Jetty server or inside a Docker container as well. Then it is simple to test because we don't have much of interdependency between various services unlike in microservices. Here we have all the functional units bundled in a single application, so any change in any of the module can be tested easily. It is simple to scale horizontally. Since this is a monolithic architecture, then we cannot scale it vertically, but anyhow we can scale this particular application into a horizontal level, right? So we can have multiple instances of this application behind the load balancer which can serve the multiple requests which is coming from the client and all. However, once the application becomes large and the team grows in size, this approach has number of drawbacks as well that become increasingly significant. So let us now see what are the disadvantages with time application grows in size. All right. So let's say we have developed our application way back in 1990 and today is 2020. So we have come long way. We have added millions of lines of code in that application. We have added multiple business functionalities, new functionalities in that particular application. So it is very natural for that application to grow in size, right? And since it grows in size, it is also less maintainable and it becomes more complex because all the functionalities are bundled together in a single application. The second disadvantage is the larger the application becomes, the longer it takes to start up. Obviously, we don't have here multiple smaller units so that we can deploy or we can start those individual services independently, right? Here we have a single unit, a single application which is very large, which is very bulky. So the startup time also is very much affected by the size of that application over the time as it increases. In a large monolithic application, if you do any change in any of the module, we have to deploy that whole entire application, right? So continuous deployment becomes difficult because even though other modules are not affected by that change, but still we have to deploy the entire application. Let's say the notification service module needs less hardware requirement as compared to the map service module, which is very heavy and which will be most used feature of the application. But in this monolithic architecture, we have no way to allocate hardwares according to the modules which is available in the application. So scaling is pretty much difficult in monolithic architecture. If we have microservices architecture, then the scaling is a different perspective there. It is very difficult to adopt new technology stack. In some way, a monolithic architecture forces you to marry to a technology stack basically because over a time application grows in size and there is no way out to change the technology because it's a single bundled application, right? Also, any bug in any of the module inside this application can potentially bring down the entire application because other modules can also be affected. Redeployment of entire application is required for any update. Let's say we have updated the payment service inside this particular entire application and the module is not going to affect other module, but still we have to redeploy the whole application and there will be a downtime for the application user, right? Now, microservices architecture is the solution to the drawbacks which we faced in monolithic architecture. So it solves these challenges of monolithic systems by being as modular as possible. In the simplest form, they help build an application as a suite of small services, each running in its own process and are independently deployable. As you can see in this particular diagram, We have multiple clients, passenger and driver trying to reach this application through an API gateway, and all the requests are routed to the multiple microservices which are dedicated to specific functional units. Payment related functionalities are present in payment service. Map related functionalities are present in map service. So the application has been broken down into multiple microservices. Each services is handling a single responsibility basically. They have their own database and they communicate through each other through a REST call or through messages. As you can see here, the same monolithic application which has all these business functionalities of trip service, payment service, map service were bundled in a single application, right? But in this microservices architecture, we have broken down all those functionalities, all those business units into different microservices which are responsible to carry out those specific functionality only. All the microservices will have their own database. Let's say one of the service is down, but other services can work independent of that service, right? And the entire application can also be functioning. So now let us see what are the advantages of an microservices architecture. The first advantage is it is highly maintainable and testable. Since we have broken down the business unit into different microservices, so each of the microservices can be maintained and tested individually. Microservices are loosely coupled with other services. So this is one of the highlight of microservices architecture because they are loosely coupled with other services. Independent deployment. Yes, since we have broken down the business unit into different microservices, so each of the microservices can be deployed individually irrespective of the other microservice. Polyglot architecture. One of the disadvantages of monolithic architecture was the complexity in adapting new technology stack. But in microservices, we have multiple smaller services. Suppose let's say instead of Java, we want to go with Python. Instead of Spring Framework, we want to go with Node.js, right? In that scenario, we will have that flexibility in microservices architecture to go ahead and choose our technology stack for a different microservices. Simpler for new developer to understand. Obviously, in a monolithic architecture, the developer has to understand each and every module, how it is working together in cohesive nature in an entire application. But in microservices, the particular developer will be handled a particular service, right? So he has to only go through the functionality of those service. So it is very simpler for a new developer to understand and get started working in a microservices environment. Faster starting time and deployment. Since the microservices are so small that they are only responsible for a single functionality. So the size of the microservices are very small. So the starting time and deployments of those services are faster as compared to the monolithic architecture. Supports both X and Y axis of scaling. So here, what are X and Y axis of scaling? So X axis of scaling is basically cloning your application into multiple instances. So in monolithic architecture, we can only scale our application in an X axis scaling because we cannot break down the modules into different microservices, right? Then it will become microservices architecture. So X axis of scaling is basically creating multiple instances of a service. So monolithic architecture is an X axis of scaling, but in microservices architecture, we can also scale along Y axis. So basically we can break down a service into multiple smaller service, and that way we can also scale vertically. And obviously X axis scaling is also available because we can create multiple instances of a service so that it will be readily available for users so that it can cater the multiple requests coming from the client. Improved fault isolation. For example, if there is a memory leak in one of the service, then only that service will be affected. The other services will continue to handle request. In comparison, one misbehaving component of a monolithic architecture can bring down the entire system as a whole. Then we have ease of choice of hardwares. Let's say in our application we have a functionality which is very CPU intensive, right? And for that particular functionality, for that particular business unit, we need more hardware. But in some other scenario, there are some business module which is not so CPU intensive and they can also work in an in-memory kind of situation. So for that particular module, we can also use Amazon's in-memory EC2 instance, right? In monolithic architecture, we don't have that flexibility to allocate hardwares based on the need of that particular business unit. But in microservices architecture, since each of the services are separate from each other, we can allocate what hardware is needed for that particular service. So we have an ease of choice of hardwares. Now, these are the advantages for microservices. Now, let us see there are some drawbacks also for microservices. What are those drawbacks? So, the very first drawback of microservices architecture is that its complexity in creating a complex distributed system. Since monolithic architecture is also a distributed system because we are interacting with database which is in different machine and we are interacting with message queue, let's say for example, which are in different machine. But that distributed system is a very simple in nature. But with microservices, where there are so many movable parts, where there are so many microservices, so many database involved, so many queues involved, So here the complexity increases to basically create or manage that kind of distributed system. Second is implementation of inter-service communication mechanism, right? So there are multiple services available. One service can communicate with any other services through REST calls. The services can communicate through each other via a message queue. There needs to be an implementation of inter-service communication which should be common across all the service. Then partition database architecture. So this is a very important point because microservices have their own database, right? So they will interact, they will write the data to those database, they will read the data from that database only. They cannot go and read the data from other microservices databases. That is not possible in microservices architecture. But from a business point of view, there can be a situation where there are some business update which is happening across multiple databases, right? So in those scenarios, multiple databases needs to be updated for a particular transaction. So that also creates some kind of challenges in microservices architecture. Testing is difficult due to interdependency on the services, right? Although the services are loosely coupled, but there are some flow which are dependent on the one of the other services. So if any one of the services is being changed, the other service might have some breaking changes. To test that, we have to have either both the services up and running and tested, or at least we have to have the dependency or the mock stub available of that services in the service which we are changing. So testing is somewhat challenging in microservices environment. It is difficult to implement changes which are spanning across multiple services. For example, let's say trip service is dependent on payment service and payment service is depending upon the pooling service, right? So anything which we are changing in pooling service will going to affect the payment service and trip service, right? So these kind of changes which are spanned across multiple services needs to be deployed and carry forward in a phased manner, right? So we have to have first pooling services deployed, then we have to have payment services deployed, then we have to have a trip service deployed. So this kind of deployment schedule we have to plan in a microservices architecture. Each service will have multiple runtime instances, which means more moving parts that needs to be configured, deployed, scaled, and monitored. Obviously, since in microservices architecture we have multiple microservices, we have multiple databases, we have multiple message queues available, we have multiple running instances of each and every microservices available, right? So to handle this, to maintain this, and to configure these kind of movable, we need to have a DevOps team which is highly effective and talented to be able to scale, monitor, and configure this kind of complex architecture. So we need to have a high level of automation in microservices architecture so that this configuration can be handled effectively. Now, the big question which arises is which should we choose, a monolith or a microservices? All right. So microservices should not be the default option because we have seen so many of good things about microservices, and we have always seen that monolithic architecture is not a very good architecture. Instead, go for microservices and all. But this should not be the case. We should not think or we should not see microservices as the only default option, because whenever we are choosing our architecture stack for an application, we should keep in our mind that what service architecture can help us. So let's say if you're not so sure about microservices architecture, then what we can do is we can start with a monolithic architecture, and we can break one of the modules into a separate service, and we can go towards microservices architecture from this monolithic architecture, right? We can evolve from there basically. All right. So it's basically dependent upon what kind of problem this application solves, what is the number of user which is going to interact with the application, what will be the scalability factor for that particular application, how much of instances we will be needing to cater the number of requests to meet the SLA which we are expecting in a future or a long run. So all of these scenarios will be taken put together, and then we can decide on which architecture we should follow, right? So if you see today, Uber, then Netflix, then Amazon, all of these great companies have started from monolithic architecture only. But as they have evolved their business, as the time grew, their monolithic application grew, and then they decided to modularize those applications into a single smaller chunks into a microservices architecture. So the shift from monolithic to microservices was not abrupt, was not very sudden. It took a long process. Thought process had gone into the architectural style, what should be the followed, and then they have migrated from monolithic. It does not mean that we only have one approach, which is microservices architecture. If you have any question, do comment down in the video, and I'll see you in the next video. Till then, bye bye, happy coding.